Welcome to MiceTech Talk with the technical information scientists of the Jackson Laboratory. My name is Caitlin, and I'm joined by my teammates Xing Tong, Dolores, Sarah, and Janine.
Our team serves the research community by guiding you the important mouse-related resources by phone, email, and educational presentations.
Since we're currently not traveling to offer that education in person, we created MiceTech Talk to address your questions live. If you're watching live, please use the comment section of the video to tell us where you are viewing from, and importantly, share with us any related questions you may have.
And we love to encourage dialogue between scientists. So if you have a question for us, we'll try and get to them as many as we can. But if you see something you can answer in the comments, feel free to reach out. Scientists helping scientists is great, and that's what we're here for.
So a few weeks ago on episode 21, the MiceTech Talk team here shared 5 different freely available database resources. Since our show is only 15-20 minutes, we can only give you a taste of each of those. So we put it to you viewers to vote on which one you wanted to see more of. So today, let's talk
your favorite databases. All right. And the winner was MGI. MGI is a great database to spend some time in. There's so many useful features that are just really relevant to mouse-related research. And it really links out to all the other different databases. So it's a great one to spend a little bit of extra time in. And one thing I wanted to mention is that we are going to be sharing our screen again like last time. This can look a little bit small if you're on a phone, but we do record these talks, so you can always go watch again later on the computer if you're having trouble seeing some of the details that we're pointing out. So let's start where we left off. Dolores, I love your t-shirt.
Oh, thank you. Thank you. I think I was not the only one with the same idea. So let me remind people, post your questions in the comment section if you want to ask anything. I see that we have some viewers from Germany. Hi, Christopher from the MMRC in Davis, California, very close to where we are. And Jacob from state of Washington, I believe. So welcome. We are thrilled to have you listening in to our MGI database. So MGI, as we said before, allows you to look for phenotypes that are described for mouse models. And you can look it by genotype, by genetic background, and by affected systems. So I often use this database to find out what is the genotype of a specific disease model. And let me share my screen for a moment and tell you what I'm talking about. Give me just a second here. Okay, I see it flashing. I hope it's not flashing for you guys.
It's flashing for me.
It is definitely flashing.
It is flashing. Oh, okay. Let me stop that and do it again. Oh, that's better. Okay, so this is an example of the Black 6 diabetic model that we are looking here, and it's a mutation on the leptin receptor gene. And as you can see here, for example, if you click on price and availability, you see that we offer 2 different genotypes. We offer heterozygous for this particular mutation or homozygous for that particular mutation. And a lot of times we get calls from customers wondering which one is the actual model of diabetes. Is it heterozygous or is it homozygous? And a quick way to find that out is if you go to the genetics section and click on the leptin receptor DB allele information, there's a link here, this blue box that links out to MGI. So if you click that, it will take you to the MGI database. You can see that you're looking at all the information about leptin receptor for this particular allele, is the diabetes allele on this gene. And if you scroll down, what I like about it is that you can see right away that is homozygous, the genotype that corresponds to the disease model. And more than that, you can see that there are actually, in this case, 11 different mouse models that have been published where the mutation is homozygous for the gene. And you can see on the right-hand side here, some of the models. The first one is on BLAC6 background. We have it on BKS background, FBB, and so on. So the next thing that I like to do when looking at this is like, how do you select which model for leptin receptor DB, in this case, should I pick? And that's a typical question from customers that reach us out at our tech support line or send us an email. And this particular table from MGI, the phenotypes and affected system table, is great for that, because really at the end of the day, what you want to make sure is that the model that you select expresses the phenotype of your interest. As you know, there's no perfect model for any disease, but here's a quick way to look at which background will give you the phenotype that you want. And as an example, I'm going to show you side by side here, comment side by side on HM3, which is the homozygous DBDB on BLAC6 background, compared to HM4, which is a mutation on the BKS genetic background. So they are side by side, so it's good to look at it. And each check mark, it means it expresses the phenotype that you want. So, for example, HM4, which is the BKS, if you look at this, it can tell you which systems, behavioral or neurological, are affected. And the other thing is you can actually click on it. So let's say we are interested in that part, the behavior and neurological aspect, and you can click on the check box, and it will show you specifically which phenotypes are affected in this particular genetic background. If you scroll up, it will tell you this is the homozygous version, as you can see up here, and it's on the BKS genetic background, and it also links to the actual journals that have described this particular phenotype on those models. So that's something that is very, very helpful when people are trying to decide which mouse model to get, and I find it extremely useful.
And I love to point out that grid in the beginning that you in the previous page that you showed, it's one of my favorite things. This is where I usually go when I really want to really dive into very specific phenotypes, because you can open up each of those little arrows, really find the details. And I love that links out to the papers, because that's a great way to be able to really see how was it studied, what exactly did the authors do to really assess that phenotype. So it's one of my favorite parts of MGI.
Absolutely, absolutely. So Janine, why don't you share with us what MGI has to offer as far as Cre Resources?
Sure. I couldn't quite hear you, Dolores, but I think you were pointing to me.
I was.
So I think your sound is a little bit funny. Anyhow, I hope my sound's okay.
We can hear you.
Yeah. So the other resource we looked at last time we were together that I presented was also in Mouse Genome Informatics, and I was presenting the Cre. So here's where we are at Prerecombinase for Cre activity. So any of you who are trying to make tissue-specific modifications, you might be interested in this resource. So I showed you this resource last time, and I showed you how you can search for a Cre strain by tissue of interest. But the only thing I didn't get to show you was this drop down here, assayed in versus detected in, and it's a pretty important distinction that I think deserves some time. So you guys probably know that Cre is a protein that recognizes specific DNA sequences in the genome, and these are called LOXP sites. And what it does is recombines those. Or another researcher may have oriented these LOXP LOXP sites in the genome and where they're oriented. You can make different types of genetic modifications knowing that the Cre protein is going to come in and recombine them. So to get a tissue-specific modification, you have to choose a Cre that is being driven by a promoter that only has activity in certain cell types. So
Janine, I think we're losing you a little bit. I missed a little bit what you just said.
Oh, boo. Well, hopefully I'm back. I don't know how else to fix it. You guys might have to step in for me. Am I back?
Yes.
Yep. I think so, yes.
Okay, cool. All right, so to make a tissue-specific modification, you need to choose a Cre that is being driven by a tissue-specific promoter, or a promoter that only has activity in certain cell types. So it seems pretty straightforward. Where you have a Prerecombinase and you have a LOXP together in the same tissue, you'll get that recombination. But something that we've noticed is that since the beginning when this technology became available is that the promoters that we think are specific aren't actually as specific as we think they are. And we also know that the activity of that promoter or that Cre can depend on how much of the promoter was used and put into that mouse strain, and then also where and how many copies of the Cre integrated into the genome. So there's a possibility that there are potential off-target effects with any kind of Cre recombinase, and that means you're going to get expression of that Cre recombinase in tissues you maybe didn't want them in. And that could be very problematic if you're trying to figure out the function of that gene in just one tissue. So when you're picking a Cre, you really want to look for data where that Cre strain has been bred to a reporter strain, allowing you to visually see what tissues have Cre activity in them. And this resource in MGI summarizes this data really, really well. So I did the same kind of search in cardiac muscle tissue using the assayed in, detected in, and the detected in and nowhere else. So I'll show you that right now and show you what the difference between all of those. So the first one is activity assayed in. And for all of these results, what I really want to point out is that they all answer the question of what tissues did researchers actually look in, and was that Cre recombinase activity present or not? And you'll see that listed in these two columns here, whether the recombinase activity was detected in your tissue of interest or if there was no activity detected in your tissue of interest. So this one where what they assayed in or what tissues did you look in is going to give you the largest number of results here, 160 different results. So that's the first one, and these are all different Cre strains, driven by different promoters. The second one is activity detected in. So now what this does is puts your tissue of interest just in this column here. But then again, you'll also notice here are the other tissues that they were looked at that do not have expression, and then also other tissues that they looked at that also have expression in addition to your tissue of interest. And then finally, the last filter to add on there is activity detected in and nowhere else. So this is going to give you the most stringent filter where this now only has 3 different results. But you'll notice here that your tissue of interest is the only thing in which there is activity detected in. And again, you get this list of other tissues that were detected in. So if you see a blank, that means they may not have looked at other tissues. You have to be really careful when you're poking through here.
That's where it's really great to go to the actual data to see what did people look at and how did this data get curated and where did it come from?
Absolutely.
Mm-hmm.
Yeah.
Another thing I want to mention here is that you see we also have the find mice column from this page, and which means we may have the strain in public repositories or not. See, you see the number 1, you can click on that and it will lead you to the link to where this mutant allele, this strain might be available. For this one, it is available at EMA repository. It is not from JAX, but it is from one of the European repositories. So for those who may not have the resource, you may consider to contact the researchers directly to see if you can obtain any live animals from the researcher directly.
Yeah, I think that's like a common misconception that like people see MGI and they see it's associated with JAKs and they think that we have all of the strains. But that's also the really cool thing about this database is that it's scraping, well, people are looking at mouse strains and curating them to this database, and it doesn't matter where they're located. It's, you know, if you can find it in literature, someone is going to try and put it into this database.
Yep.
Yeah, and another really interesting thing about sort of this summary page is the filter allele by options. They're right above where the strain list starts. And I think that's really an underutilized area. So I use it most frequently when I'm searching for tamoxifen inducible Cre strains. And so if you click on the inducer tab and select tamoxifen, down there at the last one, that is going to filter all of the results and only give you tamoxifen inducible models. So that's going to get rid of everything else and really narrow down your results.
Yeah.
I think it goes to show that you have to sort of do multiple different things to try. Sometimes there's a lot of models to pick from and you really have to find different ways to filter. Sometimes there's only a couple and sometimes there's none. So you really have to try searching in a lot of different ways to find the strain for you.
Yeah, Sarah, that's a good segue. You mentioned about looking at them. So you can filter different ways. The other thing you want to do is actually, like, you know, this is kind of a good first pass, but then you want to like dig into the actual data. So these Cre strains in this database have been bred to some sort of reporter strain. And so the coolest thing I think of this is you can then, you know, basically pre-shop for the expression pattern or what's known in this database. So for example, like this particular ACTA2 Cre, you can actually go and look in the cardiovascular system and it says, there is expression here. And you can go and say, oh yes, there is cardiac muscle tissue expression. And then the really great thing about this is you can go to the images, which I have on this open tab here. So if you actually go to the image of this particular strain and you look at the heart tissue, you can actually zoom in on this. And you can actually see like when they did this is like a LAC-Z staining, and you can see how much of that tissue is actually being, has Cre activity. So if you saw this one and you're like, I really want to have expression in heart, like this might not be a great
It's not a strong expressor.
Yeah. So conversely, you can go to another strain. So here's another one. I did the same thing. This is an MYH6 Cre, and you can go into that data and then look at this one, which is really great. It has heart at postnatal day 7. It's also got different embryonic days, but like you can see, like that's very clearly like a heart image right there. Yeah, the staining right there. There we go. Like that's like pretty nice expression.
Yeah. So I just wanted to say one comment, Janine, that before I started working at the Jackson lab, I thought that all the strains that express Cre were really, number one, good expressors, and number two, they express what they were supposed to express. And apparently that's not the case. So I just wanted, not for all the strains, I say most of the strains, they have unexpected expression patterns. So this link in MGI is really great to see the good, the bad, and the ugly, if you will, as far as how good a strain is and what to expect from it. And if you have been working with a strain for years, you can still come back here and see what the actual expression may be. And that will help you interpret your results better. Because one thing is that you interpret your result as being knockout, let's say, only in heart, which is, you know, a set of conclusions that you can take. Another thing is to say, well, it's knockout in heart, but in addition, knockout in liver, in the brain, and on whatever else. So I think if anything else, it lets you interpret your results better.
And if I can tag on to what Dolores just mentioned about, you know, even if you've been working with a particular Cre model for a while, one of the things I love about MGI is that a lot of this data is uploaded from users. So
yes,
so as you said, you can be working with it for a while. There may be new data that's been published that has been uploaded, and it's still good to continue to come back. And the other thing is, if you find some really unique expression patterns for a Cre strain that you don't see in MGI, please, this is what the kind of database is helpful for, is for helping all users to be able to understand their Cre strains.
That's all I had for Cre.
All right, Xingtong, you want to wrap it up for us?
Okay. So you see, we still have the linked few resources in this video description. And our next MiceTech talk is called Let's Talk Caring for Immunodeficient Mice on Tuesday, November 17th. And we will have one of our clinical veterinarians at that time. So we look forward to seeing you on the LinkedIn and on YouTube. And this is Dr. Xingtong, Dr. Caitlin, Sarah, Dolores, and Janine saying things healthy, stay safe, and stay excited about your research.